values. When we're talking about a squared and b squared, I could technically write this equation as 6 squared plus 8 squared equals x squared. And you'll see that it doesn't change the value of the equation. We'll get the exact same answer. We'll still get 100 equals x squared. And then we square root both sides, and we get x equals 10. So it doesn't matter which order we put a and b in, we should get the same answer either way. That's important. The hypotenuse does matter, though. We need to make sure we identify that hypotenuse correctly for solving these Pythagorean theorem problems. Another important thing to note real quick here, whenever we undo a square, we talk about this a lot in quadratics, we technically get like a plus or minus 10. So you could have x equals positive 10 or x equals negative 10. But we can't have negative values in real world situations, or like on a distance. You can't have negative distance, I guess is the best way to put it. So what that means is we can't have a length of negative 10. It's got to be a positive number. So that's why we don't really care about the positive plus and minus situation in these types of problems. We only care about the positive values only. All right, so that's what's going on with these problems here. All right, so for something like problem 2, I get 9 squared plus x squared equals 15 squared. This time, the 15 has to be on the opposite side of the equation because that's the hypotenuse of the triangle. I'm going to get 81 plus x squared equals 225. I subtract 81 from both sides, and I'm going to get x squared equals 144. And then I can square root both sides. And I'm just going to end up with x equals 12 for problem 2. For problem 3, I have 8 squared plus x squared equals 17 squared. 8 squared is 64. 17 squared is 289. I subtract 64 from both sides, and I get x squared equals 225. And then I can square root both sides, and I get x equals 15. And then the last problem here for these first 4, looks like I have the 2 legs again, so I'm going to say 30 squared plus 16 squared equals x squared. 30 squared is 900. 16 squared is 256. So I get 1156 equals x squared. And then I have to square root both sides. And square root of 1156 actually turns out to be a nice whole number. It comes out to 34. All right, so that's how we would do something. That's how we would do problems 1 through 4 there with the Pythagorean theorem. All right, the second part is SOHCAHTOA. That's sine. You might remember SOHCAHTOA. It was sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. So let's write that down real quick. We say, sine of x, we'll just say degrees, equals opposite over hypotenuse. And we'll talk about what that means a little bit more in just a second here. Cosine of x degrees equals adjacent over hypotenuse. And then the last part is tangent. Tangent of x degrees equals opposite over adjacent. And when we use these words, hypotenuse, we should hopefully know, is always going to be the opposite side of the right angle, the longest side of the triangle. All right. Opposite is always going to be the side farthest away from the current angle. So in this example, sine of 12 opposite is going to be all the way over here to the opposite side. That's how we would do something like this. So sine of x means the opposite side over the hypotenuse. That's how we would set this particular problem up. So for problems 5 through 8, it says sketch a triangle with the given angle and label the sides that will produce the ratio. So I'm asking you to do sketch a triangle, label one of them 55 degrees, and then we'll say, okay, the opposite side's over here because it's sine, and then the hypotenuse is up here. And then go ahead and put it in your calculator. And when you're doing things on your calculator, trig functions here, you got to make sure your calculator is in degree mode, not radian mode. So degree mode is going to be DEG on your calculator. Radian mode looks like rad, R-A-D on your calculator. Must be in degree mode. Okay. Otherwise it will not work. And we talked about radians last year in AGS3. We'll review them this year when we get to circular functions in Mod 6. But you need to know when you need to be in degree mode, when you need to be in radian mode on your calculator. If you're using your smartphone, like an iPhone, you can put your calculator app up. If you rotate it, the bottom left corner of your phone says rad or DEG degrees, and you can change your mode. So right now it says rad, which is actually a little confusing because it's in degree mode. And if you push the rad button, it changes it to radian mode. And you'll see the word rad showing up on the top left-hand side. So I push that button again, and then the radians go away. So that's how I'm in degree mode on my calculator. All right. So I can use my calculator to find these particular problems. Put sine of 55 into my calculator. Round it to 4 decimal places. This comes out to 0.8192. That's what problem 5 looks like. Problem 6, cosine of 38. Sketch a quick triangle. Triangles might always look different. We might not have the same drawing as each other, which is perfectly fine. Cosine adjacent means the side next to the angle. Hypotenuse, always the side opposite of the right angle. And then we plug that into our calculator and we get 0.7880. You know you're in degree mode if you're getting the same values that I'm writing down here. If you're getting different values, that means you're in radian mode and you need to change your settings for your calculator. All right, so really important that you double check that when you're putting these into your calculator. All right, last couple problems here. Tangent of 60 degrees. I'll go ahead and draw one here. Oops, I don't need that whole side. All right, so we'll make this a 60-degree angle. Tangent's going to be opposite over adjacent. We don't need the hypotenuse for this one. And that comes out to 1.7321, 4 decimal places. And then final problem here, sine of 45 degrees. So we'll put 45 degrees here. I'll say this is the opposite side. This is the hypotenuse. Plug it into my calculator, 0.7071. Rounded to 4 decimal places. Okay, so that covers the warm-up for today. Any questions on those 8 warm-up problems so far? No? Well, good. So mod 5 is going to rely heavily on that problems. First thing I want to mention again is just, we'll write it down, sine of x is opposite over hypotenuse. We'll just put over h. Cosine of x degrees is adjacent over hypotenuse, a over h. And then tangent of x degrees was opposite over adjacent. If I'm looking at the first problem here, we'll zoom out just a little bit so you can see that. First problem here, it's a sketch a triangle, so the triangle's already sketched for us, and label the sides that will produce the ratio, and then solve for x to the nearest 2 decimal places. So the triangle's already sketched for us in the example, which is nice. And I see that I have 12 degrees, and then I have the adjacent side and the hypotenuse. So if I were to set this ratio up, I would say cosine of 12 degrees, because cosine deals with the adjacent side, and the hypotenuse equals 15 over x. And then I need to solve for x algebraically. So I can put cosine of 12 into my calculator and I'll get some weird decimal answer. Or I can hold off on doing that and I want to solve for this equation first. So I got to get x by itself on one side of the equation. But because it's in the denominator, that's kind of tricky. I have to multiply both sides by x. So a numerator by x. And that's going to get rid of the x's on the right side of the equation. This is just like what we did in mod 4 with those rational functions, right? Trying to get x's out of denominators. So now I have this x times cosine of 12 degrees equals 15. And then I have to undo this multiplication of x times. So I'm going to divide both sides by cosine of 12 degrees. And that means my cosine of 12 degrees will go away on the left side of the equation. And I'm left with x equals 15 divided by cosine of 12 degrees. And now I can go ahead and put that into my calculator, and I'm going to round to 2 decimal places this time. So the nearest hundredth. So I just go ahead and do 15 divided by my cosine of 12. And I should get something like 15.34 when I round to the nearest hundredth. Make sure you're paying attention because it was 15.335, but I have to round up since I'm rounding the nearest hundredth there. So that's what my example looks like here. What I want you guys to do for these 8 problems here, try them out. But the first thing, sketch the triangle. So I'll just do the first one with you. Sine of 40 degrees. So I'll draw my triangle. I'll make a 40-degree angle. Opposite's going to be x. Hypotenuse is going to be 18. Sketch the triangle. And now you want to solve for x. This one's a little easier than the example I did before because 18 is in the denominator, so I just need to multiply both sides by 18. So 18 times sine of 40 equals x. And then I put that into my calculator and I get x equals 11.57 when it's rounded to the nearest hundredth, 2 decimal places. Remember, 40 degrees is opposite side x. Opposite because of sine. Okay. I want you guys to try the other 7 problems now. So give the other 7 a try. Take a few minutes to work on those 7 problems. Hopefully you guys have had enough time to look at these problems, try and get them set up. I'm just going to sketch some out real quick, and then we can talk about some if you have questions. Problems 4 and 7 are actually the exact same. That was just a mistake. So we can break that down real quick. All right. Problem 2. Set up a 29-degree angle there. And it's tangent, so the opposite's going to be x. The adjacent's going to be 112. I'm going to multiply both sides by 112 so I can get x by itself. X equals 112 times tangent of 29 degrees. And then I go ahead and throw that in my calculator. X equals 62.08. Remember that your drawings might not look exactly like mine, and that's perfectly fine. We are all drawing them differently. We never know quite what they'll look like, so that's perfectly fine. As long as you have them labeled correctly, that's the most important thing. So there's a lot of different ways we could see a triangle laid out. So the right angle could be down like this example here. And then if I put a 14 degrees somewhere, I'm going to say the adjacent side is, or sorry, the opposite side is going to be way over here. And the hypotenuse is going to be opposite that angle. So opposite, even though it's weird orientation of the triangle, we still have to be able to identify that right angle and then figure it out accordingly. This one multiply x by both sides, so we get x times sine of 14 degrees equals 4. Divide both sides by sine of 14. And something like that. Okay. And then we go ahead and solve, and we get x equals 16.53. Okay, for number 5, we set up our triangle. We need to multiply both sides by 15, so we get 15 times sine of 70 degrees equals x plus 2. And then we put that 15 times sine 70 in our calculator, we get something like 14.1 equals x plus 2. We subtract 2 from both sides, we get 12.1 equals x. Problem number 6. Tangent of 52 degrees. It's going to be opposite over adjacent, 2x over 13. Multiply both sides by 13. 13 times tangent of 52 equals 2x. I can technically divide both sides by 2 as well. So 13 times tangent of 52 divided by 2 equals x. Plug that into my calculator and I get 8.32. Problem 7, we already said was the same as problem 4. And then the last one, cosine of 41. So I draw a 41 degree angle, cosine is going to be 12. And then the hypotenuse is 4 over x, or 4 plus x. I can multiply 4 plus x to both sides. So I get 4 plus x times cosine of 41 equals 12. Divide both sides by cosine of 41. And I get 4 plus x equals 12 over cosine of 41. And I put that into my calculator. 4 plus x equals, what does that come out to? 15.9. And then I subtract 4 from both sides. I get x equals 11.9. All right. That's the idea for those 8 problems in particular. So that's if we're looking for a missing side of a triangle. If we're looking for missing side, hold on, I'll zoom out a little bit here, sorry. Give you guys a second to make sure you check your answers. So if we're missing a side of a triangle, that's how we would do that type of problem, okay? If we're missing an angle for a triangle, one way we can do it is we can do like a guess and check method, where we look at something like this one says using trigonometry to find missing angles. And what we can do is we can go ahead and say, let's guess at the measure of angle A here. So we can say, let's say angle A is 65 degrees. That's going to be my guess for angle A here. And now the trig equation for that, if I were to write one, I would just say, looking at where angle A is, we're dealing with the adjacent side and the hypotenuse. So that tells me katoa. So katoa, that's going to be cosine of angle A equals 10 over 20. That's how I'd write a trig equation. Remember, measure of angle A, this is literally a guess. I don't know if 65 degrees is right. That was just kind of my guess for it. And then it says write the fraction as a decimal. So I want to do 10 divided by 20. And that's like 1/2, or it's 0.5. So I want to now figure out which angle gets closest to the matching fraction when you guess and check in a calculator. So I want to try a few different things. Like I'll start with my 65 degree guess. Try cosine of 65 in your calculator and see what you get. And if I do that, I get a 0.42. So not quite correct. So then I'd say, okay, so I need to get to 0.5. So maybe I'll increase my angle. We'll say, let's try cosine of 70 degrees. We'll try a 70-degree angle instead. Excuse me. And I get 0.34 actually. Well, that's not right. That's actually going the opposite way. My number's getting smaller rather than bigger. So let me try going smaller instead. We'll go 60 degrees because going up in the degrees is making those numbers smaller. And I tried cosine 60, and there it is. I got a 0.5. Perfect. So that means the measure of angle A turns out to be 60 degrees. Okay. And that's how we can find angle measures, by this guess and check method. If we did problem number 2 here, this time we're going to try a measure of angle B and not measure of angle A. Sorry about that. What angle? What do we want to guess for this angle here? Anyone have any guesses for that angle? What they want to start it with? It looks like it's a smaller angle, right? Not the bigger angle. So it's not going to be 90 degrees. 90 degrees is this one right here. So we know it's not going to be 90. 17. 17 is a good guess. Let's start with 17 then. Yeah. Okay. So if we start with like a 17-degree angle, we'll say let's start with that. Okay. So now we set up our trig equation for angle B, and this one's going to be opposite over adjacent. So that's a tangent function. Tangent of B equals 18 over 40. We're going to write our 18 over 40 as a decimal. That's going to be 0.45. And then we're going to figure out which angle gets the closest. So we're going to have to do some guessing and checking here. So start by calculating our tangent of 45. Or I'm sorry, not tangent of 45, tangent of 17. All right, and we get 0.30. 0.3, it's actually 0.31 if we round to the nearest hundredth. So not quite 0.45, so maybe we'll go bigger. Let's try tangent of, we'll try tangent of 20. And see if we're going up or down. That's the first thing we want to figure out. Tangent of 20 is 0.36, so we're getting closer. Let's try tangent of 30. Okay, and we just try and keep guessing until we get something closer. Tangent of 30 is 0.58. So that's too high, so it's got to be between 20 and 30. Tangent of 25. 0.47, very close. So let's try 24. Tangent of 24 is 0.45. So that's it. We're saying found it. Measure of angle B equals 24 degrees. So that one took us a little longer to get to. But again, if we have an educated guess at the beginning, it's going to help us with a good starting point. That's the idea with these particular problems. But yeah, it's not all that great to be like guessing and checking for these types of problems. So there is an algebraic way to solve these inverse trig problems. And that's where we use the inverse operation of whatever sine is and whatever tangent is. All right, in inverse operations, like we do know inverse operations already. For example, like the inverse operation of addition is subtraction. The inverse operation of multiplication is division. And the inverse operation of taking a sine is called a sine inverse. And the way that works is theoretically, if I started with this sine of A equals 15 over 35, the inverse would be to take, it's like negative 1 power. We would say, let's take sine inverse of both sides. And what that really does is it makes the left side just A, and the right side is now sine inverse of 15 over 35ths. So again, it's just like sine and sine inverse kind of go away, and we're left with just the A. So that's how we would do an inverse operation. It does say sketch a triangle for these ones, so I do want to do a quick sketch. And I'll say, okay, well, the opposite side of angle A, we'll say this is angle A. Opposite side is going to be 15. Hypotenuse is going to be 35. That's what my sketch looks like. I go ahead and slap this thing into my calculator. And I'm going to find out the measure of angle A is 25.4 degrees. It says round to the nearest tenth, nearest one decimal place. So that's what I'd put in there for my measure of angle A. All right. So there's problems 2, 3, and 4. I want you guys to try those 3 problems. So give them a shot, draw the triangle, and see if you can find the inverse operation. And for these ones, like let me show you on number 2 real quick, actually, before I let you go. You can just rewrite it as, hey, B equals tangent inverse of 5/7. You don't need to show me that operation step every time. Just rewrite it like that. Okay? And then try plugging that into your calculator, the tangent inverse. The way where you find those on your calculator, unfortunately they're not on your phone, but the way you'd find them on your calculators, they're directly above the sine, cosine, and tangent buttons. So you would just hit the second and then sine inverse, and then second cosine inverse, second tangent inverse. So if you don't have one of those calculators, a scientific calculator, which is like $10 at Staples or something like that, or Target, you should try and get one because you'll need these scientific function buttons for these particular problems. So you can do those inverse problems. All right. So now go ahead and draw the triangles for 2, 3, and 4 and try these problems out. Take a minute to do that. let's look at problems 2, 3, and 4 here. So problem 2, I had it set up for you. I already drew the triangle. And we say measure of angle B. We plug into our calculator that tangent inverse, and we get the measure of angle B comes out to 35.5 degrees. And remember, we're rounding the nearest tenth, not just because I chose it, but because it tells me right here, round to the nearest tenth. So in the first problems, it said round to 4 decimal places, then it said round to 2 decimal places. This time it says round to 1 decimal place. So it's always going to say in the instructions what I want you to round to. Okay, for problem 3 here, cosine of 20 of C equals 25/38. So if I said this was angle C, 25 would be the adjacent side, the hypotenuse is 38. Doesn't matter how I draw the triangle, I gotta be able to orient the adjacent side and the hypotenuse. Okay, whoops. So then this one would be C equals cosine inverse of 25/38. Plug that into my calculator, and the measure of angle C equals 48.9 degrees. And then last one, D here. All right. I'm going to have sine of D. Put D over here, get 19/20ths. And then a sine inverse of 19/20ths equals D. And the measure of angle D is 71.8 degrees. All right. Now problem 5, actually 5, 6, and 7. I'll ask you guys to go ahead and try those 3. See if you can find the angles for 5, 6, and 7. And problem 5 says, what's wrong with this equation? So there's something going wrong with problem 5. So draw the triangle and think about what's going on wrong with that one right now. Okay, try that one out. If we assign this as angle E or something. Okay, so try those 3 problems out now. Alright, so let's take a look at problem 5 real quick. I set this up, and angle E, I'm going to go opposite, is 8. Hypotenuse is 3. So right off the bat, what's wrong with this problem? Why is this not going to work? It says, what's wrong with this equation? Anyone know what it is? Something about the hypotenuse, right? The hypotenuse is off. What do you mean by when it's off? So it's important to remember the hypotenuse is always, yeah, it says it's less than the opposite side. It can't be smaller. The hypotenuse is always, always, always the longest side. You guys got it. So that's why this one won't work. It would give me an error message if I tried to do it in my calculator. It would say not possible. So that's what's going on with problem 5 there. Okay, so it can't be smaller. It would give me an error message. For problem 6 and 7, or no, problem 6, the two examples. First it says, let's go ahead and find like angle R here. And I can set up any trig function I want. I'll just go ahead and set up sine. I'll say sine, oops. I'll just say sine of R equals 6 over 8, or not over 8, 6 over 10. And then I'll find the inverse sine inverse of 6/10 equals angle R. So I end up getting the measure of angle R equals 36.9 degrees. All right, that's what I get for angle R there. Now I would say 90 minus 36.9 equals 53.1 degrees. That's how I'm going to find the other angle. And I did that kind of fast. But what we know about triangles, the sum of all the angles always adds up to 180 degrees. So what happens then is I need to say 180 minus 90 because there's a right angle there, and I'm going to have another 90. And then I could say, well, the other two angles have to add up to 90 then. So I do 90 minus 36.9, and I get 53.1. That's how I can find the measure of angle S really quickly instead of doing another trig function. It could save me a little bit of time there. That's the idea with problem 6. All right. With the second part, if I'm looking for like angle A, I'm just gonna, because I like sine, I think that one's an easy one, I'm just gonna do sine again. We'll say sine of A equals 7 over 25. And if you wanted to, you could do another trig problem. That's not an issue. So if you like the trig problems, you like doing that, that's easy for you, then yeah, do that again. That's not a problem. That's an easy way to find the second angle as well. But you can verify that that's correct because they should add up to 90 degrees. So that's a great point there. So I'm just going to say sine inverse of 7/25. And it turns out the measure of angle A is 16.3 degrees. And then if I did 90 minus 16.3 degrees, I end up getting 73.7 degrees for angle B. All right, and that's what problem 6 looks like there.